today we are going to talk about writing a linear equation using word problems. On page 40 of your interactive notebook, this is sort of a review. You will need two highlighters, two different colors, and we're going to highlight our slope and our y-intercept throughout the entire lesson for today. So make sure you have those before you start. If you don't, pause the video, go get yourself two highlighters and come on back. Okay, slope-intercept form. Our equation is y equals mx plus b, where m is our slope and the b is our y-intercept. Taking those highlighters that I discussed that you needed, you're going to highlight every time we talk about your slope. It's going to be one certain color. In my case, I have yellow, so my slope is going to be yellow. My b, my y-intercept, is going to be green. Okay? This fits. All right, so to graph, we need an equation that we're going to graph. So my equation that I'm going to use is y equals 2/3 x minus 4. Highlighting your slope is 2/3. And your b, or y-intercept, is -4. Step 1, like we've discussed before, we're going to plot the y-intercept, or your b. In this case, it is a -4. If your graph is not labeled, you guys can go ahead and number it. 1, 2, 3, 4, and so forth. This will help you better to find your y-intercept. Our y-intercept is a -4, coming down on the y-axis and putting our first point. My y-intercept is green, so I'm going to highlight my dot, or my y-intercept, green. Step 2, we're going to use the slope to plot additional points. Use the slope, your m, to plot additional points. In this case, our m is 2/3. Means we're going to have a rise and a run positive, up and to the right and down and to the left. So we're going to go up 1, 2 to the right. 1, 2, 3. Put your first point. Up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Take your ruler and connect your points. Taking your yellow highlighter, let's show our rise of 2 and our run of 3 by creating right triangles. Looks kind of like stairs. Practical application. A contractor or an architect creating blueprints can show a rise over run for a set of stairs if they're going to build stairs in a house or a building. Okay, next we're going to talk about point test. Point test is basically asking, if we use the linear equation given, will the points 12, 4 belong to that equation? What we can do is we plug those points into the equation and solve to see if your left side equals your right side. And I'll show you exactly what I mean. So 12, 4. 12 is our x, 4 is our y. The equation we were provided was y equals 2/3x minus 4. Substituting or replacing your y for the 4, substituting or replacing your x for the 12. In this case, I'm going to write it as 12 over 1 since we have a fraction here, a ratio, minus 4. Before you multiply, if you are able to, go ahead and simplify. The idea is to try to get those denominators to 1. So 3 divided by 3 is 1. 12 divided by 3 is 4. Both my denominators are 1, so I can actually eliminate them and just cross multiply. 2 times 4 is 8, and bring down your subtract 4. Bring down the 4 on the y side. The next step, let's go ahead and subtract. Remember, you're using PEMDAS, so first we'll multiply, then we'll subtract. 8 minus 4 is 4. Does 4 equal 4? My left equals my right. If it does, then yes, the points 12, 4, or coordinates 12, 4, do belong to the linear equation y equals 2/3 x minus 4. All right, let's try the same thing with negative 16, negative 6. Again, label your x and y. Y equals 2/3 x minus 4 is our equation. Our y is negative 6. So I want the right side to ultimately come out to negative 6 to see if these points come out to equal each other in this equation. If they don't, then those points do not belong to the linear equation 2/3 x minus 4. 2/3 negative 16 over 1 minus 4. I cannot simplify before multiply, so I'm just going to cross multiply. 2 times negative 16 is a negative 32. 3 times 1 is 3 minus 4. When I subtract negative 32 over 3 minus 4, I get negative 14 and 2/3. Does negative 6 equal negative 14 over 2/3? No, they're not the same numbers on the left and the right, so they do not equal each other. So negative 16, negative 6 does not belong to the linear equation y equals 2/3 x minus 4. So this is a no. Ladies and gentlemen, glue this onto page 40 in your interactive notebook. Then we'll move on to page 41. All right, we're on page 41 of our interactive notebook. This is a continuance from the slope-intercept form graph that we were just talking about. I wanted just to give you a review of the equation y equals mx plus b, our slope-intercept form, because we're going to use that to apply into a word problem. So please make sure that you still have your 2 different color highlighters because we're going to use those in this sheet. All right, so the first thing, it says use slope-intercept form when you know a rate and a starting amount or value. When we discuss that, we're looking for some key things. When I see the word rate, it makes me think of unit rate, and unit rate means slope. So when you were on the left side, if you used yellow for slope like I did, you're going to highlight the word rate and highlight the word slope. The next thing, when I see that starting amount or value, this means that this is a one-time deal. That means that that is our y-intercept or our b. This is where we're going to start our line if we were going to graph it. So you have that starting amount, your y-intercept or your b. Remember your m for slope. Okay, let's look at an example. Using what we just talked about up here and using the slope-intercept form for word problems, it says an airplane with no fuel weighs 2,575 pounds. Each gallon of gas added to the fuel tank weighs 6 pounds. So I know the initial one-time amount is 2,575 pounds. So whether I have gas in my plane or not, it's going to weigh 2,575 pounds. Every time that I pump 1 gallon of gas, it's going to add an additional 6 pounds. This is our slope. This would be like our rise. Every time I add 6 pounds, I add more weight to the plane. We're going to use that, and we're going to try to write a linear equation. I want to discuss what your x and y will be. Your x, or the input, is the number of gallons. Which that's your input. And your output is going to be the total weight of the plane. So let's write our equation. Y equals 6 for our m, 6x. X is then if we add more gallons to the plane, plus 2,575. That's the initial weight. So every time that I pump gas, I'm going to add each gallon is going to be 6 pounds added onto that 2,575. If I start flying the plane, what's going to happen? The gas is going to decrease. So then we would end up with a negative slope. Here's positive, adding it in. Taking away the pounds would be negative slope. So again, I want you to highlight your one-time initial amount, which is your B, and then your slope, where you're adding, is your M. All right, let's talk about, I'm going to give you little hints of when you're looking at word problems for slope. Sorry about that. With slope, I want you to look for that tells the rate of change. The key word that I want you to look for, that key word, look for per. Not purr like a kitten, P-U-R, but it's P-E-R, all right? When we're talking about your y-intercept, remember it's that one-time amount, like we just discussed with the plane. It's that initial weight. This is the same thing. It tells that one-time amount. Okay, I want you to glue this into your IMN on page 41.